Before NASA astronauts set foot near the moon again, the Artemis 2 mission has to prove life support, comms, and a very, very tricky re-entry tweak. NASA has reached a major hardware milestone with the Artemis 2 mission as the Orion spacecraft named Integrity was stacked atop the Space Launch System rocket on October 21st, 2025, marking the completion of the full vehicle assembly. Now, the mission is targeting a launch no earlier than February 5th, 2026, with launch windows extending through April 26 of 2026, representing a 2-month acceleration from the previous April-only target. Now, if the February window is achieved, it will be a nighttime launch. And nighttime launches are spectacular. Now, the rocket assembly reached completion after an intensive stacking process that began back in November 2024. The core stage, featuring 4 RS-25 engines, was integrated with 2 solid rocket boosters in March 2025. Following that, the interim cryogenic propulsion stage arrived at Kennedy Space Center on April 15th and was mated to the stack on May 1st. Now, the final major piece, the Orion stage adapter, built entirely by NASA engineers at Marshall Space Center, was integrated on September 30th of 2025. Now, this ring-shaped adapter connects the rocket's upper stage to the Orion spacecraft and houses 4 12U CubeSats from international partners, including South Korea, Germany, Argentina, and Saudi Arabia, which will deploy into high Earth orbit after Orion separates. The Orion spacecraft Integrity arrived at the vehicle assembly building on October 16th, traveling from the Launch Abort System facility, where it received its 44-foot-tall abort system. Lockheed Martin completed the spacecraft's development and transferred possession to NASA's Exploration Ground Systems team on May 1st of 2025, after an extensive assembly and testing. Now, an unexpected hardware issue required NASA to replace one of the core stage's RS-25 engines. A hydraulic leak was discovered in the main oxidizer valve actuator of engine E2063, a relatively new engine assembled in 2015 that had never flown. Now, NASA swapped it with E2061, an older engine that flew on Space Shuttle missions STS-130 and STS-134 and was originally assigned to Artemis 3. Now, the engine replacement, completed by the end of April 2025, marked the first RS-25 swap in the SLS program and was performed with the core stage in vertical position, a technique previously used during the Space Shuttle era. And despite the swap, the mission timeline remained unaffected. All 4 RS-25 engines successfully completed checkout tests as part of the Space Launch System program specific engineering test series back in June of 2025, with engineers verifying seamless communication between engine controllers and also the vehicle, as well as confirming the engines could gimbal as required during flight. The Artemis 2 Orion has significant upgrades from the uncrewed Artemis 1 test flight. New systems include life support capabilities, air, water, thermal control, waste management, and displays and controls, audio communications, an exercise machine, and a fully functional launch abort system. Now, the spacecraft also features docking sensors, an experimental laser communication system to enable high data rate communications for future missions. The European Service Module, provided by the European Space Agency and built by Airbus, serves as Orion's powerhouse, supplying propulsion, electronic power generated by 15,000 solar cells on 4 solar array wings, thermal control, and life support commodities, including water and breathable oxygen. ECM-2 performed exceptionally during testing and is ready to support the crew during their journey. One of the most critical issues addressed was the heat shield performance observed during Artemis 1. And during that mission's reentry, more material than expected charred away from the ablative shield, with chunks of material liberating from the surface. Now, NASA's investigation determined the root cause. Gases produced during ablation became trapped within the heat shield material rather than permeating through it, causing internal pressure buildup that led to cracking and material loss. Rather than replacing the already installed Artemis 2 heat shield, which would have caused years of delays, NASA opted to fly the mission with a modified re-entry trajectory. The new profile reduces the skip dwell time during re-entry, which lowers heat accumulation and gas generation to levels where internal pressure won't crack the shield. NASA has validated this approach through extensive testing in arc jet facilities at Ames Research Center. Now, for Artemis 3 and beyond, the heat shield manufacturing process will be modified to make the AV coat more permeable. The environmental control and life support system is one of the most critical new additions for Artemis 2, as will be the first full test with crew aboard. The system includes carbon dioxide removal, humidity control, temperature regulation, and ventilation to maintain a habitable environment for the 4 astronauts during their 10-day mission. Now, NASA encountered and resolved several ECLSS issues during development, including problems with control valves for the carbon dioxide removal system and sealing material on valves causing overboard leakage. Both issues have been fixed, and NASA continues testing the ECLSS through multiple failure scenarios to ensure reliability. Now, the mission profile specifically includes a checkout period in high Earth orbit before committing to the translunar injection burn, allowing the crew to verify ECLSS performance and abort if necessary before heading to the moon. And the crew has been engaged in extensive training throughout 2025, practicing multiple scenarios, including nighttime launch operations, emergency egress procedures, and suited crew tests. In August, the crew practiced night launch scenarios at Kennedy Space Center, simulating suiting up, driving to the launch pad, and emergency evacuation procedures. They also completed emergency egress system demonstrations inside the vehicle assembly building, practicing with emergency egress baskets that would be used during a real emergency. The astronauts performed suited crew tests on July 31st, 2025, entering the Orion spacecraft together for the first time while wearing their Orion Crew Survival System spacesuits, testing all equipment interfaces they will operate during the mission. Now, training also includes practicing, observing, and photographing the moon from mock-up Orion capsules, learning how celestial objects will appear through Orion's windows as backup to the advanced navigation systems. Artemis 2 will be an approximate 10-day test flight following a free return trajectory, meaning that once the translunar injection burn occurs, physics and the gravitational interactions between Earth and the moon will naturally bring the crew home even if propulsion systems fail, similar to Apollo 8 and Apollo 13. However, the spacecraft will make slight trajectory corrections as needed. After launching from Kennedy Space Center's Launch Complex 39B, the SLS's rocket twin solid rocket boosters will provide approximately 75% of the vehicle's 8.8 million pounds of thrust at liftoff, with the 4 RS-25 engines providing the remaining 25%. Following booster separation and main engine cutoff, Orion will perform an apogee raise maneuver and a perigee raise burn, reaching a high Earth orbit approximately 70,000 kilometers at its highest point. During this checkout phase, the crew will test life support, displays, controls, and other critical spacecraft functions. And if all systems perform nominally, mission control will authorize the translunar injection burn on day 2. The crew will then conduct a proximity operations demonstration with the spent upper stage, practicing rendezvous and station keeping maneuvers, critical for future Artemis 3 operations when the crew will dock with the lunar lander. The mission will take the astronauts more than 5,000 nautical miles, approximately 5,523 miles or 8,889 kilometers beyond the moon's surface, the farthest humans will have traveled from Earth since Apollo 13. Now, the crew will not enter lunar orbit or land, but will complete a flyby of the moon's far side before the free return trajectory brings them back to Earth. Following the completion of vehicle stacking, NASA will conduct integrated testing in the vehicle assembly building, including a countdown demonstration test with the crew. Now, Charlie Blackwell Thompson, the Artemis launch director, indicated the fully assembled vehicle is targeted to roll out to Launch Complex 39B by the end of calendar year 2025. At the launch pad, teams will connect the rocket and the spacecraft to ground support systems. After approximately 2 weeks of preparations, they will conduct a critical wet dress rehearsal, which is a full-scale launch simulation where the SLS will be fully loaded with liquid hydrogen and oxygen propellants. And the countdown will proceed to T-minus 29 seconds before being terminated. The fuel will then be drained and the vehicle prepared for its actual launch. Unlike Artemis 1, if the wet dress rehearsal is successful, NASA does not plan to roll the vehicle back to the vehicle assembly building unless a major issue arises that cannot be resolved at the pad. Instead, they will use a new temporary platform to install the batteries that power the flight termination system directly on the pad. NASA has identified launch windows of approximately 4 to 8 days per month from February through April 2026, with the earliest opportunity on February 5th and the latest on April 26th. The specific dates within each month are still being finalized as teams work to nail down the exact daily opportunities. The acceleration of the schedule from the previous April-only target to potentially February reflects NASA's efforts to capitalize on efficiencies in operations while maintaining crew safety as the top priority. Despite ongoing concerns about SpaceX's Starship human landing system scheduled for Artemis 3 and recent announcements by acting NASA Administrator Sean Duffy about potentially reopening the lunar lander contract to additional competitors, the Artemis 2 mission remains on track. The completion of the rocket stacking and the progress toward integrated testing shows that NASA's commitment to returning humans to deep space exploration is real. We are going back to the moon. We're going to build a base there, and it is going to propel us to Mars.